Welcome to another Galaxy Science, and today we're going to talk about more stuff. Even more stuff. Yeah, more stuff. So, we humans, like I said, use air conditioners. And they're all around the globe. All around the maps. And that's what we're going to talk about today. Maps. That's what we're going to talk about today. Maps. So, the maps do stuff. They're like the maps of the world, places. Let's have the map of the world. 3, 2, 1. Done. We have the map of the world. For example, we have here Africa. Let's draw Angola. There it is, Angola. So, what I want you to see is that Angola is in the middle of Africa, and the map of the world is the map of the whole entire planet, whole itself. What kept me wondering? There is Google Earth. There is Google Earth. But what about Google? What about a Google Mars? Well, a Google Mars. It's like Google Earth, but with the maps of Mars. Well, I don't know if this can exist or not, but since we are planning to get to other planets, well, we can have the possibility of getting Google Mars. Well, I think the possibilities of going to Mars, making it the new planet it is. I think it's going to be 30%. I think it's going to be 30% of chance. But I think that the rest is going to be 70%. No. So, if the 30% wins, that means they could make Google Mars by 50-50 chance. But if the 70% wins, I think it's 30 by 70, I don't know. I think it's not going to be possible to make a Google Mars. I think it's not going to be possible to make a Google Mars. Because a Google Mars, basically Google Mars is Google Earth. Let's imagine Mars is an Earth. So we have Google Earth. And Mars is the exact same thing, but Google Mars is the exact same thing, but with Mars. So, well, I don't know if we're gonna be possible. Also, do you guys know the color of the flag of Mars? Is this one. It's not black and white, duh. It's not. It's with red, green, and blue. Well, I've already heard that we want to make Mars from a red, dry land into an ocean planet, and then to a marvelous blue and green Earth-like planet. But the thing is, I don't know this possibility is gonna work, because terraforming a planet is really hard. Let's focus on that for a bit. well, terraforming, I'm gonna call it TG. I'm gonna call it terraforming TG, which is terraforming, is basically turning a lifeless planet. Terraforming a planet is basically turning a lifeless planet to a water, beautiful life planet. And this is basically what terraforming is. This is basically what terraforming is. But my question is, in one video I saw in the future, humans will likely arrive in the other planets. And humans will arrive into other planets. They'll terraform them like Jupiter, Saturn. I hope in the future we will live in Titan. That would be beautiful. And also, we could terraform the whole Milky Way in the future. But my question is, if the humans will have terraformed all the planets, even the gas, how would they do with the gas giants? Well, we already planned to terraform Mars. But what about Jupiter, Saturn, Uranus, the butthole of the solar system, Neptune, and the other gas giants that are over there in the Milky Way? How would they do that? Well, I don't know really. Okay, so let's imagine we have here the Milky Way. Now let's talk about galaxies. The Milky Way is a giant galaxy. It contains it goes from 100,000 light years, 100,000 light years side to side. That's gigantic. But we have a galaxy that's approaching us. It's called the Andromeda. The Andromeda is reaching us, and the galaxy is moving fast. Oh, I need a new paper. 3, 2, 1. Done. So, as I was saying, the Milky Way is gigantic, but the Andromeda is bigger. The Andromeda likely contains twice the many stars on the Milky Way. And that's a lot. Scientists say it's predicted to the Milky Way. It's predicted to the Milky Way collide with the Andromeda. It is predicted that the Milky Way and Andromeda might collide with one another. And if I was alive at that time, it would be spectacular to see that collision. Imagine, when you're in the night sky, you see a galaxy approaching, and then you just smash with one another and give birth to new stars. That would be so cool. Like, really, really cool. So, I'm gonna make a thing of how it would look like if Andromeda was getting close. I mean, when it will collide with the Milky Way. Okay, so let's have today. Today is like this, with all the stars on the Milky Way sky. All of the stars that you can see in the night sky, all the stars are inside our galaxy. You cannot see any other stars after you see our galaxy. And something strange is that the scientists say if you move out of our galaxy, you cannot see it. That's strange. Well, you can see all the sky, but it's a blurry shaped one. This one is not a cloud. Is not a star. It's the Andromeda, and it's coming close. I mean, super close, like I said. Today is like this. After some years, it will have approached like this. And I think after some years, will have approach like this. You can think these are the same, but no, they're not. But after another years, it will be like this. And I think that after some years, it's gonna fill out the nice guy. Oh my god, it looks like so fat. And then it will be spectacular to see the Andromeda Milky Way galaxy collide as they give birth to new stars as the two bright collisions, as the two bright cores of the galaxy. These are the cores. And as they collide to make a super galaxy known as Milkdromeda. Yeah, Milkdromeda. I'm not kidding. It's a combination of Milky Way and Andromeda to make the gigantic Milkdromeda. Wow. Now let's talk about black holes. Black holes look good. Space really fits the theme of my channel, Galaxy Space Rocket. So, let's talk about black holes now. Black holes are one gigantic holes on the universe. You might think, oh, black holes are just gigantic black holes that are black in the universe that you can put your hand in. No, they're actually super big, and they can crush every matter into a bliss. If you get too close to a black hole, you get sucked in. But you get only sucked in when you pass the event horizon. The event horizon is a thing surrounding the black hole. It's not really surrounding, by the way. It's surrounding the black hole. Is that when it's crossed, there's no turning back. So if you want to jump to a black hole, you gotta think twice. Because when you reach the event horizon, there's no coming back. You gotta think twice. The black holes are so strong that not even light can escape while passing the event horizon. And that's why they look black. And that's called black holes. But there's a magical point in space that when light gets too close, is not sucked in, but it doesn't necessarily skip out. And this magical point of space, you can actually orbit the black hole. This can be some good news to satellites, that they can orbit black holes to study them. That would be good. But we cannot send a space probe to a black hole. The closest black hole is 1,600 light years away. That is super far. I gotta get another paper. Yeah, that's super far. But that's not the farthest thing. Andromeda is way farther. Yeah. Still is approaching, but it's far. Even though the closest black hole is 1,600 light years away, it doesn't have any effects on the Earth because we're too far away. Even though you think that black holes are super strong that can rip things apart like planets, suns, or molecules or something, you're right. But when it's too far, you cannot break it. Only when it's past the event horizon that can be broke and not get out. See, we're in peace. We're in peace. We will not get scorched by a black hole. Now, I know what I want to talk what people think that the Earth is. Flat. The Earth is not flat. It's not flat, people. They think that the Earth is like this. They think that the earth is like this? You gotta be kidding me. You gotta be that stupid. You gotta think that the earth is flat like this. Like this. You've got to be kidding me. You think that the earth is flat? Wow, which stupid idiots. They have something wrong with their brain. They have something wrong. The earth is not flat. It is round. Okay, here's some tips and tricks. The earth is not stupidly flat. So, the earth is round. And when it's flat, well, it's bad. If it was flat, let's put you in a field. Let's put that the earth is flat. When you're in this field, let's put the earth is flat. If it was flat, according to scientists, if it was flat, you can see the tallest mountains and stuff. And now, we're going to put you on the curvular earth. Let's put a curvular earth. Let's put you in a curvular earth, earth that curves. Well, you cannot see the mountains because the earth curves and you cannot see them. You can be on the other side of the earth, but that's not the case. The case is, if the earth was truly flat, you could see the highest mountains and stuff. But the earth isn't flat, it is round. That's why you cannot see the mountains from where you are. Because the earth is round and gigantic. Okay, now we're going to make another series with flat earths. This earth is flat, right? Yeah, this earth we put you on is flat. And what about the other side? Well, flat people that think that the earth is flat, I heard someone say that I think that they think that all the continents are one side and the other side doesn't matter, I think, but that's not the case. If the earth was truly flat, let's put you on the ocean. Let's put you in a flat earth. Now let's put you in the ocean. Now let's put the ocean not that sink. Now the ocean is like this from the ground. According to them, if the earth was flat, you could walk, for example, from Africa to Australia. If the oceans weren't that deep, you could walk to other places. But since the earth is round, you cannot walk to there. And you can also not see. You're seeing vision as a straight line. Okay, that's it for the video. Bye.